Lab 1, Charged Tape by Advaith Nidumukula. Ordinary objects can acquire an excess or deficiency of electrons if they are rubbed, pull apart, or touch other objects, giving the object a net charge. In this lab, two pieces of charged tape were prepared by peeling them apart from each other. Then, one piece of tape was suspended while the other was used to repel the suspended piece of tape, with the electrostatic force opposing the force of gravity. The purpose of this experiment was to determine the excess charge present on each piece of tape. The excess charge present was determined to be approximately 7.5 nanocoulombs. The electrostatic force between two charged objects is given by Coulomb's law. Force is equal to K times Q1 times Q2 over R squared, where K is Coulomb's constant, Q1 and Q2 are the charges of the objects, and R is the distance between the objects. The force of Earth's gravity is given by the equation F equals to mg, where m is the mass of the object and g is the gravitational acceleration. In this free body diagram, both the tapes are modeled as having a single point charge in the center because the charge is assumed to be evenly distributed across the tape. Air resistance is assumed to be negligible and both tapes are assumed to have the same mass and charge. When the suspended piece of tape begins to float, the force of gravity, represented by green, equals the electrostatic force, represented by orange. In the experiment, two U-tapes were prepared by peeling a 20 centimeter length of clear tape from a second piece of clear tape. The mass of the tape was approximately 0.16 grams. The U-tape was tested with a negatively charged pen. The two objects attracted, indicating the U-tape is positively charged and has a deficiency of electrons. It can be assumed that both U-tapes have the same charge since they were prepared identically. One U-tape was held by the ends and suspended between two cardboard boxes, and the second tape was held by the ends and used to make the first U-tape float. The distance between the two tapes at the point where the first tape began to float was measured to be 1.8 centimeters. In the code, the constants are defined first and come from either physical constants or experimental values. Each tape is modeled as a point charge, with the suspended piece of tape represented as being the measured distance above the held tape. The charge of each tape is given by the values calculated using Coulomb's law, and the electric force and gravitational force are assumed to be equal but opposite in direction. At the point where the suspended piece of tape begins to float, the electrostatic force and force of gravity on the tape are equal. By setting them equal, the charge of the tape can be determined. From the derivation on the right, and using the values for m, g, r, and k, which are either physical constants or measured values, an experimental value of 7.5 times 10 to the negative 9 coulombs, or 7.5 nanocoulombs for Q, the charge of each tape, is calculated. By dividing the charge of each tape by the elementary charge, 1.6 times 10 to the negative 19th coulombs, it can be determined that each U-tape has a deficiency of about 4.7 times 10 to the 10th electrons. To find the fraction of atoms which gave up electrons, we have to find the number of deficient electrons and divide that by the total number of atoms in the U-tape. Calculating the area of an atom and using that to find the number of atoms on the tape, we determine that there are approximately 2.5 times 10 to the 15th atoms on the tape, and therefore the proportion of atoms that gave up electrons is about 0.0019%. To conclude, the charge of a U-tape is approximately 7.5 nanocoulombs, and about 0.0019% of atoms on each tape gave up their electrons. Some potential sources of error in this experiment include inconsistent creating of U-tapes, which could give each one a different mass or charge, inaccurate measurement of the weight and separation distance of the U-tapes, as well as air currents that could cause the suspended tape to move, reducing the accuracy of the distance measurement. If electrons and protons had opposite charges, the tape would then be negatively charged with an equal magnitude, or negative 7.5 nanocoulombs. Since an electron and proton have the same magnitude of charge, the two U-tapes would still repel each other with the same force and cause the suspended tape to float at the same distance. However, this tape would be repelled by negatively charged objects like a pen rubbed in hair, but still be attracted to neutral objects due to dipole interactions. It is very important to handle the tapes carefully and avoid touching the center, since touching it with one's hands, which are usually neutrally charged, will cause some electrons to transfer from one's hand to the tape. This can reduce the accuracy of the measurements and calculations, which are conducted under the assumption that both tapes have the same charge. Thank you for listening to my lab report.